So I didn't put what we're going to learn, but basically we're going to solve equations today. We've been talking about exponential functions like this, for instance, right? Well, you can be given an exponential function where, you know, we have an x and a y, and maybe you could be given like a number here, right? You don't know the x, but they tell you the y. And your job is to figure out what the x is. Now I think you guys could probably look at that and know the answer is no, 2. Because it's 5 times 5, right? But it's 2. It's 5 to the second power 2, right? So that's what we're doing today. So this table, you'll probably be referencing it a lot unless you have these already in your head, like if you've memorized things like this already. Most of us have not. Some of them you probably have memorized. But we're going to be using this table a lot today, and I'll show you how we use it. But basically, we're going to want to be aware of these powers. So here's an example problem. I thought I had it animated, but it's not animated. That's very sad. All right, so let me actually back up here, and I'll do it one step at a time. So we have 4 to the x equals 8. Now, the reason this one's going to be a little bit harder than the last one I gave you because you guys know, for instance, that 5 squared is 25. That's okay for you. But this, you're not going to be able to get an answer. Now, some of you guys might think 2, because 4 times 2 is 8. But we're not doing times 2, right? It's 4 to a power equals 8. And here's the problem with that. What's 4 to the first power? What's 4 to the second power? So we skipped 8 somehow, right? That doesn't mean there's not an answer. It just means that our answer is between 1 and 2. Okay, and we have to figure out what it is. So here's how this works. Step 1 for the day is to get these numbers, which, you know, we've called them growth factor before, right? But you can also call them the base. I'll probably be referring to it as the base today. Step 1 is to get the bases to be the same, and here's how you get the bases to be the same. You look for the column that has both of these numbers in it, and that's right here. See that? They don't have to be next to each other, but you just look for the column where they're both in there somewhere. And what I'm going to do is I'm going to change that 4, and I'm going to change the 8 also. The 4 is 2 to the second power. The 8 is 2 to the third power. That's really the main step there. After that, typically you're going to have to do some kind of multiplication, like if you have a power being raised to a power, 2 times x is 2x. At that point, an equation is like a balance scale. If you take the same thing off both sides, it stays balanced, right? Well, I've got the same thing on both sides here, so I could just ignore that and just make the exponents equal to each other. And from there, you guys know how to solve. You just divide, right? So that's what this problem over here is. On your notes, I think I have the wrong answer. I put 2 over 3, but it's 3 over 2, so if you want to fix it, you can. But that's the power you would raise it to. If you want to think of it as a decimal, it's about 1.5, and sure enough, remember how we said the answer is going to be somewhere between 1 and 2? Well, there you go. So 4 to the 1.5 power is apparently equal to 8. Okay? So step 1 is the big step, changing your bases to match. After that, multiply and then solve. So that's the idea. We're going to do a couple problems today. You guys have all that already typed up, right, on your paper? Okay. All right, so let's go ahead and do our first 4 here. These are like the basic examples, and then we're going to look at 2 like weird ones, 2 weird types that we'll learn how to deal with. But these are the basic ones. So let's go ahead and start with number 1. We have 5 to the x equals 625. Okay, so my first question is, what are my bases? Well, this is a base, and this is a base. So now you're going to look at your chart that I printed out for you, and you're going to look for which column has 625 in it and some 5s. Yeah, you see that there? So now the 5 is like, you guys see that's the basic one. 5 is the one that's in every one of them. So we'll leave that one alone. That's the basic one. But over here, we do need to change to 625. What am I going to change that 625 into, according to the chart? 5 to the 4th power. Good. All right. So there's nothing wrong with that. 625 is 5 to the 4th, so I'm just replacing it with something that it's equal to, which is fine. But now that I've done that, I've got this equation with two identical things on the left and right, so we can just drop that out, which means that apparently x is 4. That's how it would stay balanced if x equals 4. Let's take a look at a second one. All right, so for this one, we have 36 equals 216 to the x. So look in your chart, see if you can find the column that has a 36 and a 216 in it. Okay, great. So we've all found it. It's in that 4th column, hopefully. We see it there. What am I going to replace the 36 with? 6 to the 2nd power and 216? 6 to the 3rd. All right. Now this one has a little something different to it. I don't know if you guys noticed how I started this off, but let me back up a little bit. This one already had a power on it, right? Well, when I prepared to fill in my blanks, I put parentheses there with that one that was already on the outside. I think that'll be helpful if you do that. So when they already have a power on them, you know, if you're going to change it, give it a blank spot and leave the power that's already there on the outside. I think that'll be helpful. You'll see why when we get to number 3 especially. All right. So since this one had that situation, we do need to put these together, and it's just multiplication. So 3 times x is 3x. You're going to drop out your bases. Because they're equal, we can just get rid of those and solve what's left. And so here we would divide by 3. And so I get x equals 2 over 3 as my final answer. And you could check this stuff on a calculator, for instance. You could do 216 to the 2/3 power. It should equal 36. Hey, it's Bailey. Hi. Yeah. Yeah. Well, you know, she should probably go to Miss Chu, because she's here to observe calculus. And right now, Chu has calculus, and I have it 4th and 5th. Bye-bye. All right, let's go ahead and take a look at our third one here. Number 3, 81 to the 2x minus 3, and 27 to the 4x plus 5. All right, so once again, you guys see how there's already powers there, right? Since there's already powers there, for those ones, I'm going to put parentheses first. I'm going to put the power that was already there outside like that. And I'm going to let you guys fill in those blanks. I'll call on you to ask you what you put there. So fill in those blanks with what you think goes there. You're going to be using your chart for that. All right, so I'm going to ask Vidal, what did you put here? Cool. Yeah. And then Stephen, what did you put here? Okay. Good. So that's the main step, getting those bases to match. Now we're going to multiply this power with this. Now the way that you're going to do that is with since this one has 2 terms in it, you're going to distribute it. So it multiplies to both. So you're going to do 4 times 2 and 4 times -3. So on the last one, it didn't have 2, so we just multiplied the 2 numbers together. But in this one, since there's 2, you can distribute that 4 to both of them. So it's going to be 3 to the 8x minus 12. Go ahead and do the other side there. I'll ask you what you got. What did you get, Danny? Great. So you distribute that 3 times both of those, and that's what you get, 12x plus 15. Jedrick, what's next? Ignore those bases, because they're the same. They don't affect the equation since they're identical. Just drop them out of there and solve. And so from here, we're going to rely on our algebra skills to finish up the problem. Notice how we have an x on both sides. We haven't seen that yet on the problem. When you have that, what I like to do is find the smaller one, like the 8, and I get rid of that one. So I'm going to subtract it. Whatever you do to one side, you do to the other. So now that 8x is gone off of the left side. And since I took 8x off the other side, I'm left with 4x here. And then I get the numbers together, the ones without x's, same thing, constant. So I'm going to get rid of the 15 here. I'm going to subtract that 15 on both sides. Negative 27. And then divide. So I end up with x equals negative 127 over 4. All right. Number 4 is just more practice, but the final answer does turn out kind of interesting. We'll see that in a second. Now hopefully you guys are kind of seeing these steps now come through, right? Change the base, simplify, set exponents equal to each other, and solve. So let's do one more. I'll go a little quicker through this one just because most of it's not different from number 3 until we get to the end. And I just want you to see what happens at the end. Okay, so first of all, I would look for the numbers in the columns, right? 256 and 16. Pretty sure 256. You guys can correct me if I'm wrong, but I think it's 2 to the 6th, right? Oh, is it 8? Thank you. And then 16 is 2 to the 4th. Then we're going to multiply. Here we multiply, but since there's 2 of them, we got to distribute. We can drop out our bases. So you guys see nothing different happening from the last problem, but this is where something interesting will happen. I'm going to solve for x. Since we have an x on both sides, I'm going to get rid of the 8x on one side, but whatever you do to one side, you do the other. So I end up with this. And we've seen that before. Do you guys remember what that means? Yeah? Oh, you're right. Negative 40. My bad. Good catch. Thank you, Jedrick. I made a mistake here, guys. When I distributed, I didn't do 4 times 10, and I just put 10. It's supposed to be 4 times 10, which is 40. So go ahead and make that little correction there. But back to the question. My x's went away, and I have 0 equals negative 40. You guys remember what that means? Because that's not true, right? 0 doesn't equal negative 40. The x is gone, so I'm not solving for x anymore. Yeah, that means there's no solution. No solution. So when your x's go away, there's two possibilities. Possibility one is there's no solution. It's no solution if those two numbers are not equal to each other. That means x goes away, so no matter what x is, these things will never be equal to each other, so there's no answer. But let's say you ended up with something like 0 equals 0. Well, in that case, that's a true statement, right? For that means no matter what x is, they're always equal. And so that's all real numbers is how you say it. So when the x's go away, it's either no solution or all real numbers. If they're not equal, no solution. If they are equal, all real numbers. All right, so there's a student practice for you guys. So I'll let you guys mess around with these. They're just like these ones. Then we'll. So we've looked at the weird situations, okay? No, we've looked at the normal situation of how to solve these problems. Now we're going to look at two weird situations. Weird situation number one is fractions. Weird situation number two is roots, okay? So let's go ahead and figure out how to do this. So first of all, we're going to start off the same way, okay, as we did with the last one. We're going to find the base number here, and we're going to rewrite it, okay? So I'm going to start by rewriting that. And what do you guys think I'm going to put for the 32? Two to the fifth, right? We look in our chart, we find what the 32 and 8 are, and we find what to replace it with. So I'm going to replace 32 with 2 to the fifth, and 8 is going to be 2 to the third. All right. Now here's the new step. Here's the step that is going to fix the weirdness of this situation. The weirdness is with a fraction. Well, we can make this not a fraction anymore. Before I show you it, let me remind you guys, do you guys remember that if I have like 2 to the negative 1, that means 1 over 2 to the positive 1? Well, it's true. Even if you forgot it, it's true. So basically what negative exponents do is they just make things become fractions. So, and we're used to going from a negative exponent and changing it into a non-negative exponent with a fraction. But actually today we're going to go backwards. We're going to turn it from a fraction back into this. So let me show you what I mean then. I don't want this to be 1 over 2 to the fifth. I just want this to be 2 to the fifth. I can make it 2 to the fifth without the 1 on top if I make the exponent a negative. That's just a property of exponents. Same thing here. I don't want this to be 1 over 2 to the third. So what am I going to make it? 2 to the negative third. So that's your correction for the weirdness. So weird situation number 1, fractions. How do you fix it? Just make the exponent a negative. That's all you have to do. All right, and from there, there's actually nothing new about it. So we're going to distribute. We're going to drop out the, if you guys got to keep the signature sheet going around so everybody gets it, yeah, just keep it going around if you plan on showing up on Thursday. We're going to drop out the bases, right? Negative 5x plus 15 equals negative 6x minus 15. And we'll solve. I'm going to add 6x on both sides. Some of you guys might be weirded out by that because so far every time today I've moved this number, not this one, but it doesn't really matter which one you cancel. So I'm going to do the 6x this time. That way this is gone. And I end up with a positive 1x. Negative 15 is all that's left on the other side because the 6x is canceled. and then solve for x. I'm just going to minus 15. So that, all this stuff is not too important to me from here and up. It's these first steps. So step 1, change your bases. Step 2, so it's not a fraction anymore, just make the exponent negative. If you get that far with it, I'm pretty happy, but definitely try to take it all the way home, okay? So here is one for you guys. Just so you guys know, this one, you're still going to change it into a different base, but you're not going to do the negative exponent on the left side because, is it a fraction? No. So since the 8's not a fraction, you're not going to do the negative exponent thing with the 8. You'll only do it on this side. So go ahead and see how you guys do with that. I'll give you a sec. All right, so that's that. So that's weird situation number 1. Let's look at weird situation number 2. I'm actually gonna do things a little bit differently here. I'm not gonna do this one. I'm gonna let you guys do this one. I'm gonna do this one over here with you instead, because it's a little bit trickier. So I figure I'll do the harder one. I'll let you guys do the easier one. All right. So here we go. What base do you think I want to change these into? 5? Yeah, nice job. We want 5s on there. Now one of them is already a 5. So we'll leave that one alone for now. But I'm going to go ahead and change this guy here into what 25 is going to be. 5 to the second. So first step is just like it always has been, change the bases so they match, right? Now here's where things are gonna, well, let's do this side first. Brianna, I don't want this to be 1 over 5 squared. So I'm gonna change it into what? Well, the ones we just did, remember how they were fractions? We didn't like it. So what do we have to do to the exponent so it's not a fraction anymore? Huh? Cancel it out? Not quite, but good shot, so I can still give you a point. Let's try, Niana, do you know? If I don't want this to be a fraction anymore, what can I change that into? Okay. Nate. Hit up Amethyst again there. Sorry, I didn't see it till late there, but I'll come to you next time.
Turn into negative?
Yeah. So I don't want that 5 squared on the bottom, so I'm just going to make it a negative 2 there, right? Now let's talk about this square root. Let's talk about that square root. We have a rule from a while back where matter of fact, I think I'll write it like this time. We have a rule where if you had something like this, you could rewrite that as b to the power of t over a. So in other words, whatever number's out here, that's going to be the denominator of your exponent. And whatever number's in here, that's going to be the numerator of your exponent. And the b is just your base. So we have a little rule there. So for instance, you know, if I had this, that would be 5 to the 2/3 power, just as an example. So that's our review. Now let's come to this problem. You might also remember that, what is this number here if it's not present? It's 2. Usually if we were missing a number, it's either 1 or 0, right? This is an exception. If we're missing a number here, it's a 2. So let's go ahead and put a 2 there. Now, what is the exponent on the 5 if it's not there? That's a 1. That's normal. All right. So if I were to rewrite this, it would be 5 to the what power? 1/2. Yeah, 1 over 2. So that's the new thing. This was review. We did that weird. That's one of our weird things. But fractions become negative. But here's our new thing. If you have a root, just change it into a fraction power. Okay. After that, nothing new. So we could put these together. We could drop out our bases. Solving this equation is going to be a little bit of a pain in the butt because we don't like fractions, right? Any thoughts on how to solve that? Yeah. Cool. We could do that actually. Let me change it to positive 2. We'll talk about the negative in a second, but so here's the thing. Whenever you have a fraction, if you don't like that, just multiply the fraction by the bottom number because that cancels it out. And you're allowed to do that so long as you also do it to the other side. So multiply this side by 2 also. So that's going to give me negative 4x equals 1. No more fractions. That's kind of how I deal with fractions. I just get rid of them. After that, I think we know just to divide. So it's negative 1/4 is our answer. There's a lot going on in this problem. Let me remind you of what I think the most important thing is I want you guys to take away from this problem now, okay? I want you to remember this rule here. If you see a radical, you change it into the power. That's the big thing I want you to take away. The rest of it, just a lot going on here. This whole thing here, you know, where you change it to a negative 2. That's another weird thing that came up. And this was another weird thing that came up. Solving the equation. Those are the little things that are good to see, but that's the big thing I want you to see. All right, so let me throw one at you guys. See how you do with that.